In this session, we will be covering the one sample t-test. First of all, we are importing pandas, numpy, matplotlib, and also just because we will be using Skype for our test, so we are also importing this stats module from Skype. When it comes to one sample t-test, it's pretty interesting. The kind of questions it tends to answer goes like this. When you are having a data and there is certain preconceived notion in form of mean, or maybe there is certain set of population that is already present and you want to compare your result to the mean of the existing population, that's when one sample t-test comes into being. To give certain example of one sample t-test, one thing could be your population in certain state, for example Himachal Pradesh versus rest of the country. Mean height of students in X school, how significantly it is different from the rest of schools in HP. Or your gender sex ratio in Kerala versus rest of the country. So when we are measuring a certain specific samples to the existing population, that's where we tend to use one sample t-test. For example's sake, we are having data set of newborn babies and their weight is being calculated here. And we will be seeing this weight with the national average weight. So average weight of a healthy kid will be somewhere between 3 to 3.5. To start with, we are importing the dataset that is already present in CSV format. I will be uploading CSV file in the description box, though I won't be keeping the Jupyter notebook because I want you to hardcode yourself. That's the reason I'm not deliberately keeping it over there. So here you can see there is a graph present. Now this particular graph is known as a PP graph. I'm sorry, a QQ graph. So why are we using QQ graph? There is an assumption that needs to be satisfied just before we go into one sample t-test. And that assumption is our data set has to be normally distributed. And in order to check the distribution of our data set, visually we can get idea of it by looking into the QQ graph. So what we can see over here is this line that is approximately 65-degree line. Your data points need to be either overlapping or be very close to it. If that is happening, it goes to show that our data is normally distributed. In this scenario, it's just going off over here, but again we can neglect this part and on it really looks like a normal distribution of our sample. So it is pretty intuitive way. At same time, we wanted to check it by using certain statistic, and a very high notch statistic is by name Shapiro test. So Shapiro test is used to identify whether our data set is coming from normal distribution or not. And therefore, we are having a null hypothesis and also alternative hypothesis. since it's a test. So null hypothesis tells that your data is normally distributed. An alternative hypothesis tells that it is not normally distributed. And again, we are not going into the mathematical part. It's just an intuitive way and more practical statistics that we are dealing with this particular playlist. Maybe I will be getting into mathematical concept. For that, I will be creating another playlist. So over here, we are writing stats.shapiro. That's how we call Shapiro statistic that is present in stats module. And inside, this is name of the data frame, that is body underscore weight. A is nothing but the column name. And once we have written this, we are getting the statistical value, and here is the p-value. So something that we have to focus on is the p-value or probability value. This value is 0.45, and since it is greater than 0.05, we reject the alternative hypothesis, that is, data is not normally distributed, and therefore we state that data is normally distributed. So first thing is proven. Till now, if you have to be with me, just understand there is nothing great we have done. Firstly, we have imported the data set. Post that, since it's one sample t-test, there is a major assumption of normality within your data that has to be satisfied before going into it. Therefore, we used QQ-plot that gave us intuitive way to understand, and then we used Shapiro test that quantifies what we really saw in this particular chart. Now finally, we are coming to our own hypothesis that is attached to one sample t-test. So what was the problem statement? Our data set is having body weight of newborn babies and whether it is matching the national average or not. In order to do this, again, statistic is present within your stats module, and then for one sample t-test we have to use t-test underscore one sam, and inside the very first part is again the data frame followed by the column where your data set is present. This additional part is your national mean. In this case, suppose I have just written 2.79. Ideally, any healthy kid will be between 3 kgs to 3.5 kgs. We have written 2.79. Let's execute this, and we are getting a value of minus 63. Since this value starts with minus, this shows that the sample which is present over here is less than 2.79. When I am telling less, I am talking about average. So that average value is way more less than 2.79. And also p-value is 0.0, so it will be 0.0000 something. Here it's just 0.0. This p-value tells that unfortunately we are rejecting the null hypothesis, that is, kids weight that is present within our data set is far less than comparison to the national average. And if that is the case, our kids are malnourished or they are underweight. So I hope you are able to realize where actually we can use one sample t-test.